Gazing upon Earth from a cosmic distance, it's easy to feel a sense of permanence. The gentle rotation, the vibrant tapestry of oceans and continents, it all suggests an enduring stability. Yet, this tranquil facade masks a precarious existence. Throughout its tumultuous history, planet Earth has endured cataclysms of cosmic proportions. Continents have split apart, mountains have risen and crumbled, and species thought invincible have vanished into the mists of time. Hidden within the vast expanse of the universe, lurking just beyond the edge of our awareness, are powers capable of reshaping and even destroying our world. These aren't the familiar dangers of wildfires or floods, but forces born from the same celestial fires that forged our solar system. Imagine gargantuan asteroids cleaving through space, their paths aimed at our fragile blue planet. Envision our life-giving sun nearing the end of its cycle, swelling into a monstrous star and devouring the very world it once nurtured. Could Earth fall into the inescapable grasp of a wandering black hole, its very essence stretched and torn until nothing remains? These aren't mere nightmares from the dark corners of the imagination. These are very real possibilities tethered to the fundamental laws of a dynamic and sometimes unforgiving universe. As inheritors of a planet teeming with life, a flicker in the long history of the cosmos, we stand at a crossroads. Do we succumb to fear, becoming paralyzed by the enormity of these potential catastrophes? Or do we harness the same curiosity that drives us to explore the stars and turn that gaze inward into the depths of scientific knowledge? It's time to embark on a journey not through space, but rather through the labyrinth of cosmic dangers that threaten the Earth. We will venture into the realm of the improbable yet possible, grappling with the terrifying magnificence of natural forces beyond our control. This isn't simply a catalogue of disasters, it's an exploration of boundaries between life and extinction, between the known and the yet unfathomable. As we peer into these potential apocalypses, unsettling questions will inevitably arise. Are we mere playthings of a capricious universe, destined for obliteration without warning? Or amidst the chaos, is there resilience, adaptability, a chance for survival against insurmountable odds? Is awareness of danger, however remote, the first step toward mitigating it? We may not find all the answers. Some cosmic mysteries defy solutions, leaving us suspended in a state of wonder, perhaps with a tinge of terror, before the sheer scale of it all. Yet, even in the face of potential oblivion, there's a strange beauty to be found. For in confronting the fragility of existence, we gain a profound appreciation for the precious, unlikely gift of life on our planet Earth. Asteroid impact and hypercane. Throughout its history, Earth has endured countless cosmic collisions. Asteroids, remnants of the solar system's chaotic formation, bear down on our planet. Most of these are minor, leaving scars but no lasting devastation. However, lurking within the depths of space are far larger objects, and on the scale of cosmic time, a catastrophic encounter is inevitable. Imagine an asteroid a kilometer wide or more, a mountain of rock hurtling through the void at tens of thousands of kilometers per hour. Such an object carries the energy of millions of atomic bombs. If it collided with Earth, the consequences wouldn't be confined to a single region. The very foundations of our planet would be shaken, potentially triggering an extinction event to rival that which ended the reign of the dinosaurs. To grasp the sheer magnitude of this threat, let's dissect the terrifying physics of an asteroid impact. The moment of annihilation. An asteroid of this size wouldn't simply slam into Earth, it would detonate. Upon impact, the asteroid's immense kinetic energy, a product of its incredible mass and speed, would be converted into an explosive force of unimaginable power. The asteroid and the impact site would be utterly vaporized in an instant. The Earth's crust would melt, behaving more like a liquid than solid rock, as a crater hundreds of kilometers wide forms within seconds. A ring of fire temperatures at the impact zone would soar to levels hotter than the surface of the sun. A blinding flash followed by a colossal shockwave carrying superheated air would sweep outwards, incinerating everything in its path. Molten rock, blasted from the crater, would streak across the sky, raining fiery debris across vast distances. Seismic fury. The energy wouldn't dissipate at the crater's rim. Shockwaves would ripple through the Earth's crust, traveling at incredible speeds for thousands of miles. These seismic waves would trigger devastating earthquakes far from the impact zone, shattering landscapes and potentially destabilizing dormant volcanoes, adding to the unfolding chaos. If the impact happened on land, the devastation would be horrific. But our oceans cover most of our planet, and a cosmic collision at sea would unleash a unique and perhaps even more terrifying chain of events. Oceanic fury. A large asteroid plunging into the ocean would create an incomprehensible explosion. A vast volume of seawater would flash into steam in an instant, creating an expanding bubble of superheated water vapor and fragmented rock. This titanic blast wouldn't just displace water, it would be a detonation, transforming the ocean itself into a weapon of planetary devastation. Unstoppable tsunamis. The expanding bubble would displace unimaginable amounts of ocean water, giving rise to colossal tsunamis unlike any ever witnessed. These waves wouldn't be mere tens of meters high, but could crest at hundreds of meters, dwarfing skyscrapers. Propelled by the raw energy of the impact, they would radiate outwards in all directions, inundating coastlines across the globe. The destruction wrought by an asteroid impact, whether on land or sea, would fundamentally alter Earth. But the true horror, the power to trigger a global extinction event, lies not in the immediate devastation, but in the cataclysmic aftermath, the birth of a monstrous storm known as a hypercane. Winds of doom. While familiar hurricanes are fueled by the warmth of tropical oceans, a hypercane would be a different beast. Its engine wouldn't be warm water, but the colossal energy released by the impact itself. Picture storm winds not merely exceeding hundreds of kilometers per hour, but reaching the speed of sound itself. These winds would scour the landscape, flattening forests and stripping away topsoil. Continental chaos. The hypercane's reach wouldn't be measured in hundreds of miles. It could potentially engulf entire continents in its relentless fury. The storm's unimaginable wind speeds would drive mountainous waves, compounding the destruction already wrought by the impact-driven tsunamis. The immediate catastrophic destruction wrought by a hypercane would be horrific, yet it might not be the ultimate extinction event. The lingering consequences could reshape Earth in ways that challenge our ability to comprehend, let alone survive. Artificial winter. The hypercane, fueled by the asteroid's impact, would pump enormous amounts of debris, water vapor, and ash into the upper atmosphere. This vast shroud of dust and vapor could veil the Earth, blocking out life-giving sunlight for months or even years. A prolonged artificial winter would descend upon the planet. Temperatures would plummet, wreaking havoc on ecosystems worldwide. Collapse of the food chain. Plants, the foundation of many food chains, are particularly vulnerable to sudden reductions in sunlight. Imagine vast swathes of forests dying, crops withering in barren fields, and algae blooms choking once thriving aquatic ecosystems. Creatures relying on those plants for sustenance would starve, and those that prey on them would face the same fate, cascading up to wipe out entire branches of the web of life. A world in darkness. Even if humanity somehow found havens from the immediate destruction in bunkers deep underground, their survival would hang by a thread. With food production at a standstill, supplies would eventually dwindle. The prolonged darkness and unnatural chill would ravage any hope for surface agriculture. What sort of society might emerge from such a prolonged period of deprivation and darkness? And lurking beneath the surface is an even more insidious threat. Ozone depletion. The colossal energy from the asteroid impact could have a devastating effect on the ozone layer, our planet's vital shield against harmful ultraviolet radiation from the sun. A shattered ozone layer would have profound and long-lasting consequences for all life on Earth. Even after the dust eventually settles, sunlight would no longer be life-giving. It would be a bringer of death. Radiation's toll. Exposure to intense ultraviolet, UV, radiation causes damage at the cellular level. In plants, it can disrupt photosynthesis and damage vital tissues. Animals, including humans, would face an onslaught of cancers, mutations, and bizarre genetic defects passed down through generations. Would Earth ever fully recover from such devastation? This is a question that haunts both scientists and philosophers. While life is remarkably tenacious, finding a foothold in even the harshest environments, the hypercane and its aftermath would leave deep, lasting scars. Could new ecosystems, fueled by radiation-resistant organisms, arise from the ashes of the old? Perhaps. Yet, the vibrant biosphere we've inherited would forever be lost. This raises a chilling philosophical question. Can a planet ever be truly destroyed? Even if life endures in some diminished form, if a fundamental characteristic of Earth is irrevocably altered, rendering it forever hostile to the vibrant ecosystems it once sustained, haven't we lost something irreplaceable? Does destruction lie not only in the absence of life, but in the irreversible shattering of its potential? Jupiter becoming a star, transitioning from devastation. As we stare into the abyss of a ravaged Earth, with its broken atmosphere and dimmed sun, we might yearn for the warmth and security that celestial bodies promise. Yet, even the stars themselves are not immune to transformation. Could our mighty neighbor, the gas giant Jupiter, harbor the potential to ignite into a star, forever altering the dynamics of our solar system and potentially plunging an already battered Earth into a new crisis? The cosmic dance. Jupiter, with a mass greater than all the other planets in our solar system combined, is a world of swirling storms and swirling colors. Yet, hidden beneath those swirling clouds lies an intriguing truth. Jupiter possesses the raw ingredients of a star. Composition: a star in waiting. Like our Sun, Jupiter is composed primarily of hydrogen and helium, the two most abundant elements in the universe. Stars themselves are colossal spheres of these gases, ignited by the relentless crush of their own gravity. The immense pressures in a star's core fuse hydrogen atoms together, releasing staggering amounts of energy, the light and heat that power solar systems. The difference of scale. So what stops Jupiter, with all its hydrogen, from achieving stellar ignition? Simply put, it's not massive enough. To trigger that critical process of nuclear fusion, achieving that dazzling state of stardom, Jupiter would need approximately 80 times its current mass. But what if that immense mass could somehow be gained? But the universe is not static. Stars are born, planets migrate, and cosmic collisions are a matter of when, not if. Could a series of events unfold that drastically increase Jupiter's mass, pushing it across that crucial stellar threshold? A rogue star's embrace. Imagine a rogue star, one not bound to any system, hurtling through the depths of space. If its path intersected our solar system, the gravitational disruption could be significant. Asteroids could be flung into chaotic orbits, potentially bombarding Jupiter and contributing to its mass. Another possibility lies within our existing solar system. If two stars formed in close proximity, a complex gravitational dance might occur. The smaller one might gradually be pulled apart, its material siphoned by the larger star. While the Sun is the dominant presence in our system, a catastrophic event could put Jupiter in a position to grow at the expense of another smaller celestial body. A cosmic feeding frenzy. Asteroids aren't the only objects out there. The remnants of planetary formations swirl around stars, including dwarf planets and icy planetoids. Under the right chaotic gravitational conditions, Jupiter could act like a cosmic vacuum cleaner, sweeping up vast swaths of material over eons, slowly but surely increasing its mass. These scenarios offer a glimpse into the dynamic nature of our universe. While they might seem wildly improbable, remember that we are discussing the potential for events occurring over hundreds of millions or even billions of years. In the grand scheme of cosmic time, even unlikely events have a chance to unfold. But let's assume Jupiter could somehow overcome its size deficit and cross that critical threshold into stardom. What would this mean for Earth and the rest of our solar system? The very idea of Jupiter, that familiar beacon in the night sky, transforming into a second sun, is both awe-inspiring and terrifying. The immediate effects on our planet would depend entirely on the dynamics of the ignition process. A swift transformation. A rapid shift triggered by a sudden influx of material and the swift collapse of Jupiter's core might have dire consequences. The sudden change in the gravitational balance of the solar system could send planets careening into new, wildly eccentric orbits. Earth might be flung perilously close to the newfound star, potentially scorching our planet to a cinder. At the opposite extreme, we might be ejected from the solar system entirely, becoming a rogue planet hurtling through the icy depths of interstellar space. A gradual change. If Jupiter's transformation occurred over a more extended period, the consequences could still be dramatic, albeit less sudden. A second star in our solar system, even a dim and small one by astronomical standards, would significantly alter Earth's energy budget. Radiation levels could spike, potentially overwhelming what remains of our protective ozone after the asteroid impact. The added heat might be enough to trigger a runaway greenhouse effect, vaporizing any remnants of our oceans and rendering Earth utterly inhospitable to life as we know it. It's essential to remember that our solar system has been a relatively calm place for billions of years. This equilibrium has allowed life to evolve and thrive. The ignition of a second star, even a small one, would disrupt this delicate balance, potentially in ways impossible to predict. Beyond the immediate threat to Earth, Jupiter's transformation would irrevocably alter the night sky. No longer just a bright point of light, it would transform into a glowing celestial orb, potentially casting shadows and even competing with the faint light of distant stars. This cosmic metamorphosis would fundamentally challenge our understanding of the universe and our place within it. A philosophical quandary. Throughout history, humanity has turned to the heavens for guidance, for solace, and for inspiration. We've charted our course by the stars and based our mythologies on the constellations that grace our night sky. What happens to this deep-rooted connection when the celestial bodies themselves can no longer be seen as constant? This raises an unsettling question. Is safety and predictability essential for life, especially intelligent life, to exist and flourish? Could the mere potential for such cosmic upheaval cast a shadow of existential dread over any civilization that reaches our level of awareness? Exploring the outer solar system. Jupiter's transformation into a star wouldn't just devastate the inner planets. Its effects would ripple out to the farthest reaches of the solar system. Moons in disarray. Jupiter boasts an impressive retinue of moons, some larger than planets. The gravitational shift caused by its ignition would likely throw these moons into chaos. Some could be ejected from the Jovian system entirely, becoming rogue bodies themselves. Others might collide, creating spectacular displays visible across vast distances, but also adding to the potential for debris to rain down elsewhere in the solar system. Ice giants disrupted. The ice giants Uranus and Neptune would feel the change acutely. Their orbits, carefully sculpted by the gravitational balance over billions of years, would likely destabilize. Like Earth, they could be flung closer to the new star, or perhaps even ejected into interstellar space. We might witness collisions between moons and planets, cataclysms beyond our wildest imagination. The asteroid belt's fury. The boundary between the inner and outer planets is marked by the asteroid belt, a vast collection of rocky remnants from the formation of our solar system. Imagine the disruption caused when Jupiter, with its now vastly enhanced gravitational influence, starts tugging on these asteroids. Earth could find itself bombarded by a wave of debris, bringing another large-scale extinction event as its neighbor transforms into a star, adding a layer of intrigue. The idea of a star forming within a familiar solar system raises another fascinating possibility. What if inhabited planets already existed around Jupiter before its transformation? A doomed civilization? Imagine a world orbiting Jupiter, close enough to harness its power, perhaps with civilizations adapted to its unique radiation environment. That world and its inhabitants would face an imminent apocalypse as their life-supporting gas giant became a life-consuming star. Could they escape? Would there be time? Witnesses to a cosmic spectacle. Perhaps intelligent life existed on more distant moons around Jupiter. They would bear witness firsthand to the terrifying and beautiful transformation of their once familiar planetary guardian into a star, a sight no other civilization in the universe would have likely experienced. Let's shift our gaze from stellar birth to stellar death. The possibility of Jupiter transforming into a star, however remote, forces us to confront the impermanence of even seemingly familiar celestial bodies. Yet, Even as we grapple with the idea of new stars igniting, there's another, perhaps even more unavoidable, cosmic deadline looming large: the inevitable demise of our life-giving sun. While it has sustained Earth for billions of years, the laws of physics dictate that its journey must come to an end. And in its death throes, the sun holds the power to reshape our world beyond recognition. The sun's expansion, a star's life cycle. Like a living being, stars are born, they age, and eventually, they die. Our sun is currently in the prime of its life, a main sequence star, steadily converting hydrogen into helium within its fiery core. This process has provided a seemingly endless source of energy for billions of years, nurturing life on Earth. But the celestial fires are not inexhaustible. Change at the core. As the sun exhausts its fuel supply in its core, a profound imbalance sets in. The relentless outward pressure of energy from fusion can no longer counterbalance the inward crush of gravity. This signals a dramatic turning point, the beginning of the end for our life-giving star. Without the outward push of fusion, the sun's core begins to contract, becoming smaller and denser. A monstrous transformation. Paradoxically, as the core collapses, the sun's outer layers balloon outward, driven by complex changes within its interior. This cosmic act of defiance marks the sun's transformation into a red giant. Picture our star swelling to 100 times its current size or even more, its bloated form dominating the sky, glowing an ominous reddish hue as it casts an eerie crimson light across our world. The sun's relentless expansion would have devastating consequences for Earth. As its bloated form encroaches upon our planet, it might consume us entirely. The once life-giving star would become our celestial executioner, engulfing Earth in a fiery embrace. While this might be the ultimate end of our world, the sun's death throes would also present a chilling possibility. What if, before its final demise, it flung Earth into the desolate, frozen reaches of interstellar space? This cosmic upheaval forces us to confront a harsh truth. Even if humanity somehow manages to survive the many threats that lie in wait, ultimately, we are at the mercy of forces far beyond our control. The delicate balance that has allowed life to flourish on Earth is ephemeral, a fleeting moment in the grand cosmic timescale. Are we, as a species, capable of accepting the fragility of our existence? Can we find the will to explore, to seek out new havens, even knowing that our efforts might ultimately be in vain against the unyielding forces of the universe? Or will we succumb to a sense of despair and futility in the face of our eventual, unavoidable doom? This brings us to the next chilling threat on our cosmic voyage, one that lurks unseen, an invisible danger with the potential to snatch Earth away without warning. Let's venture into the realm of black holes and the unsettling possibilities they represent. Being pulled into a black hole. Born from the death throes of massive stars, black holes are regions where the very fabric of space-time is warped beyond recognition. Their gravitational pull is so immense that nothing, not even light, can escape once it crosses a boundary known as the event horizon. This makes black holes invisible to our telescopes, detectable only by their effects on the space and matter around them. Imagine a wandering black hole, invisible and silent, entering the outskirts of our solar system. At first, its presence might go entirely unnoticed, but as it drew closer, its gravitational influence would begin to make itself known. Planets might be nudged off their familiar orbits, their paths becoming erratic and unpredictable. A wave of asteroids and comets could be pulled out of the Kuiper Belt or the Oort cloud, setting them loose on potentially Earth-bound trajectories. As the black hole continues its inexorable approach, Earth itself would feel the gravitational tug. This wouldn't merely be like tides caused by the moon, but a profound distortion of the very fabric of our world. Earthquakes unlike any ever experienced would rack the planet, potentially triggering tsunamis and shattering the crust. Yet the most terrifying effects would occur as Earth drew closer to that invisible abyss. If it crossed the event horizon, the point of no return, a bizarre and inescapable fate would await. The immense tidal forces near a black hole would stretch and distort Earth in an agonizing process known as spaghettification. Our planet, once a vibrant sphere, would be elongated, pulled into a thin filament before being ultimately torn apart and consumed by the cosmic abyss. While the chances of an encounter with a black hole are astronomically low, the sheer destructive potential is undeniable. This chilling scenario raises profound questions. Could any technology, however advanced, protect us from such a monstrous force? And what would it mean for a civilization to fall victim to a cosmic force it couldn't see, couldn't fight, and couldn't escape? Transitioning from the cosmic to the earthly. From an encounter with the monstrous forces of black holes, we now shift our focus to a threat closer to home, the potential for a devastating chain reaction of volcanic eruptions rocking our planet. Unlike our previous threats, this stems not from the stars, but from the churning, fiery heart of Earth itself. Simultaneous volcanic eruptions. Beneath the seemingly stable surface of our world lies a molten realm of unimaginable power. Volcanoes act as vents for this internal pressure, spewing lava, ash, and gases, reshaping landscapes in often dramatic fashion. Yet, these familiar eruptions, while devastating locally, are nothing compared to the global threat posed by a different kind of volcanic activity: flood basalts and mass extinctions. Scientists have uncovered evidence of colossal volcanic events known as flood basalt eruptions throughout Earth's history. Unlike the cone-shaped volcanoes we're familiar with, these events involve vast outpourings of lava through fissures in the Earth's crust. These eruptions can last for thousands or even millions of years, covering immense swathes of land with layers of basalt rock. The connection between these flood basalt events and extinction events in the fossil record is chilling. The mass extinction that ended the reign of the dinosaurs, for example, may be linked to a large igneous province eruption. But how can events confined to Earth's surface trigger such devastating and widespread loss of species? Choking ash clouds. Volcanic eruptions don't just produce lava, they release immense quantities of ash and gases into the atmosphere. A global chain of super eruptions would shroud the Earth, plunging it into a prolonged volcanic winter. Plants would wither without sunlight, food chains would collapse, and those not killed by the initial eruptions could face a lingering death through starvation and a hostile climate. Toxic atmosphere. Volcanoes release toxic gases, including sulfur dioxide and carbon dioxide. A surge of these gases could cause widespread acid rain and a greenhouse effect far exceeding the impact of human industry. This altered atmosphere would be toxic not just to animals, but to whole ecosystems, changing the very chemistry of our planet. Could it happen again? Large igneous provinces exist around the Earth, remnants of past planet-altering events. While the odds of them all erupting simultaneously are low, it's not outside the realm of possibility. Even the eruption of a single large igneous province could have devastating consequences, disrupting food production worldwide and leading to mass die-offs. Exploring the consequences, global devastation, a world in darkness. The sheer volume of ash and volcanic debris ejected into the atmosphere by a series of eruptions would block sunlight on a global scale. This would mimic the effects of an asteroid-induced winter, but would likely be even more severe and prolonged. Temperatures would plummet, plunging vast regions of the planet into a long and potentially deadly chill. Collapse of agriculture. Plants depend on sunlight for photosynthesis. Even a partial reduction can have a cascading effect. Large-scale crop failures would lead to famine and a struggle for dwindling resources. Those relying on livestock would find their herds decimated, further destabilizing an already strained food supply. The global food chain, the very basis upon which human society rests, would be stretched to its breaking point and perhaps snap entirely. Poisonous air and toxic waters. Volcanoes spew out noxious gases that can create a deadly atmospheric cocktail. Sulfur dioxide is a powerful contributor to acid rain, which could ravage forests and poison water bodies and soil. Increased carbon dioxide would amplify the greenhouse effect, potentially leading to extreme and unpredictable weather patterns and a rapid acceleration of global warming, causing its own set of cascading problems. Redefining maps. Large-scale volcanic eruptions build new landforms, reshaping coastlines and even creating new islands. However, such dramatic geological changes would come at a terrible price. Existing coastlines would be swallowed by lava flows, displacing entire populations. Fertile agricultural land could be buried under layers of rock, making the famine crisis even worse in the long term. Mass extinctions. The fossil record clearly links past volcanic events to sudden upticks in the extinction rate. A simultaneous eruption today could be equally devastating. Species uniquely adapted to specific ecosystems would be hardest hit by rapid changes in temperature, air quality, and food availability. The very biodiversity of our planet would be jeopardized, with profound consequences for generations to come. Facing the fragility of our systems. This threat highlights the delicate balance of our world's systems. Humans tend to think in terms of years, decades, or at most, centuries. We take the relative stability of our planet for granted. But Earth has a far longer and far more violent history. The simultaneous eruption of large igneous provinces is a reminder that the very ground beneath our feet might not be as solid as we believe. Could humanity find safe havens underground? Would technology be enough to mitigate the food shortages? And on a less practical level, what would it do to our collective psyche to witness the powerlessness of human constructs, cities, borders, systems of commerce, in the face of such planetary fury? Unraveling stability, our daily lives. We live our lives within a framework of assumed constants. The Earth rotates at a predictable rate, giving us day and night. The tilt of its axis determines our seasons, shaping weather patterns and ecosystems worldwide. But what if those constants were called into question? Axial disruption. Large-scale volcanic events release immense energy from Earth's interior. This sudden imbalance of forces could be enough to cause a slight shift in the planet's axis of rotation. Even a minor change would have far-reaching consequences. Imagine days or nights becoming longer or shorter, with the transitions occurring over mere weeks rather than months. This sudden disruption would be devastating for any life adapted to Earth's established rhythms. Scramble in the seasons. Along with changes to day length, an altered axial tilt would destabilize the familiar patterns of seasons. Regions with temperate climates might plunge into a permanent winter, while polar latitudes could become unbearably hot. Migrations, mating cycles, and countless delicate biological balances honed over millennia would be thrown into chaos. Time in turmoil. Our systems of timekeeping are tied to the predictable rotation of the Earth. Suddenly, clocks would become inaccurate. The very definition of a day or a year would need adjustment. This isn't merely a societal inconvenience, it's a fundamental assault on our understanding of order in the universe. Imagine the chaos for modern systems that rely on precision timing, navigation, communication, and countless others. The aftermath, a planet reset. The eventual waning of volcanic activity wouldn't immediately lead to a return to normalcy. The Earth that emerged would be fundamentally different, its geography altered, its climate zones scrambled, and biodiversity decimated. Even if human civilization somehow clings to survival, the scars inflicted by such an event would be borne for generations. This cataclysm raises a chilling possibility. Perhaps what we perceive as a stable planet is actually a temporary state within a far more dynamic Earth system. Could we recognize the warning signs of another super-eruption building, or would we be blindsided by natural forces we barely comprehend? The struggle to adapt. The direct effects of super-eruptions, ash clouds, climate shifts, etc., are terrifyingly immediate. Yet, the true horror lies in the chain of long-term consequences for both natural ecosystems and any human survivors. A world of extremophiles. Extremophiles, organisms that thrive in harsh environments, would be the most likely inheritors of a volcanically transformed world. With sunlight blocked, food chains built on photosynthesis might collapse entirely. But ecosystems built around geothermal vents on land or on the ocean floor might see an unexpected boom. These alien-like life forms, adapted to heat and toxic chemicals, could form the basis of a new, drastically simplified biosphere on Earth. Desperation-driven technology. Faced with starvation and a radically altered climate, survivors would turn to untested and potentially unsustainable technologies. Artificial light for underground farms, the development of genetically modified crops able to survive the harsh conditions. These would be high-stakes gambles. Success might buy time. Failure would mean extinction. Shattered societies. Our global society, built on connectivity and specialization, would likely collapse under this strain. Survivors would be forced into small, isolated communities focused solely on basic needs. The knowledge and cultural richness of humanity could be fractured and scattered, perhaps lost in the struggle for mere existence. A philosophical challenge. The threat of simultaneous volcanic eruptions forces us to grapple with geological timescales. For all our ingenuity, humans are a species that thinks in terms of lifetimes and generations, rarely in millennia. Can we grasp the true age of our Earth, the slow build-up of forces unleashed in sudden, devastating ways? Is it possible to maintain a sense of urgency about long-term threats that exist beyond the scope of any single human's experience? It also challenges our notion of what Earth means. Is it merely the familiar world of today, or is it the sum total of its changes throughout time? Ice ages, volcanic periods, and all potential futures? If Earth itself is ephemeral on a cosmic scale, is it hubris to think of ourselves as anything more than a temporary occupant? Earth's rotation, reaching light speed. Throughout our exploration of potential apocalypses, we've confronted the fragility of Earth. Asteroids, solar expansion, and even the fiery forces within our planet all threaten our world with devastation. Yet, the final cataclysm in our journey might be the most bizarre and unsettling, a fundamental breakdown of the laws of physics as we understand them. Picture this. Some unknown force or event causes the rotation of our planet to gradually increase. At first, the changes would be subtle, mere fractions of a second added to or subtracted from the length of a day. But the acceleration continues relentlessly. Days shorten into hours and hours into minutes. What started as a minor inconvenience quickly spirals into a world-altering catastrophe. But the true terror lies not merely in a faster turning Earth, it lies in the approaching a cosmic limit, the speed of light. According to Einstein's theory of relativity, nothing with mass can reach or exceed that speed. But what happens if an entire planet is set on a collision course with this universal barrier? Exploring the physics of the impossible. As Earth's rotation approaches a significant fraction of the speed of light, the familiar laws of physics begin to break down. Time dilation. Time itself slows down for objects moving at speeds approaching that of light. A clock on the fast-spinning Earth would tick slower compared to one in space. This effect would intensify with higher speed, eventually leading to a complete standstill of time at the surface if light speed were reached. Mass and energy. Einstein demonstrated that mass and energy are equivalent. As Earth spins faster, its kinetic energy would increase, and thus its mass would increase as well. This accelerating increase in mass would require a never-ending source of energy, and the gravitational pull of the Earth would intensify with dire consequences for anything remaining on its surface. The distortion of space-time. The very fabric of space-time around our planet would become warped. As the Earth nears light speed, it could theoretically punch a hole through space-time itself, with unpredictable and potentially catastrophic consequences. Extreme scenarios. Even though the possibility of Earth reaching light speed is strictly a thought experiment, it's illustrative to consider the extreme ways reality would unravel under such circumstances. Flattening Earth. The Earth's current shape is slightly flattened at the poles and bulging around the equator due to rotation. As the rotation accelerates, this effect would increase dramatically. The Earth would eventually transform into a thin, pancake-like disk with immensely powerful centrifugal forces tearing it apart from the inside out. Gravity unbound. Imagine standing on Earth's surface as it spins faster and faster. The stronger gravity would make it increasingly difficult to move, to resist being crushed. At some point, even buildings rooted into the ground might begin to lift as gravitational forces are outmatched by centrifugal ones. Finally, the surface of Earth itself would start to disintegrate, flinging debris as the planet tears itself apart. Annihilation. Ultimately, Einstein's theory dictates that as Earth approaches light speed, its mass would approach infinity. This would create a gravitational singularity similar to a black hole. Earth, as we understand it, would cease to exist and likely be replaced by a vortex consuming anything in its vicinity. This event wouldn't just devastate Earth, it could distort the very fabric of our solar system. The philosophical edge. Beyond the physical destruction, this scenario raises deep philosophical questions about our understanding of the universe. Are the laws constant? We base our scientific understanding on the fundamental laws of physics. Yet, could there be unimaginable scenarios under which those very laws break down? What does this say about our ability to comprehend the boundaries of the cosmos, the limits of prediction? If Earth began spinning faster, how long could scientists predict the devastating consequences? Could we escape in time? This highlights the limits of human knowledge and the potential for cosmic events to unfold in ways exceeding our understanding. It's a humbling, perhaps terrifying reminder of our smallness in the vast expanse of existence. Solar system disruption. The consequences wouldn't be confined to Earth alone. The escalating changes in our planet's rotation, mass, and gravitational pull would have profound effects on the delicate balance of the solar system. Lunar chaos. The Moon's orbit is stabilized by its gravitational interaction with Earth. A faster spinning, more massive and eventually disintegrating Earth would throw the Moon's orbit into chaos. The Moon could be flung away from Earth entirely, sent careening into space as a rogue body, or it could spiral inwards, eventually crashing into the remnants of our world. Planets off-kilter. The gravitational influence of the planets on each other maintains their stable orbits. A rapidly changing Earth would disrupt this delicate dance. Other planets could be pulled into dangerously eccentric orbits, potentially leading to collisions or even ejection from the solar system. Rain of debris. The disintegration of Earth wouldn't be a clean process. A vast cloud of debris, pulverized rock, fragments of buildings, relics of our existence, would be flung out in all directions. This would create a cosmic minefield, with the other planets, moons, and the asteroid belt at risk of being bombarded for an extended period. A dying star's influence. Even if somehow the Sun didn't react catastrophically to the gravitational changes, unlikely, but let's assume it as a thought exercise, the dying Sun itself is a volatile element in the equation. The increased mass of a disintegrating Earth could, for example, pull it closer into the expanding red giant phase, accelerating its destruction. Or, the cloud of debris might block light and heat from other planets, hastening a deep freeze across the solar system. The unpredictable cosmos. It's important to note that any attempt to model these effects is purely a thought experiment. The unpredictable physics at extreme light speeds and the complexity of a multi-body solar system would make accurate predictions impossible. This reinforces the terrifying lack of control we have over the ultimate fate of our world and its neighbors. Our journey through the realm of potential cataclysms has been one of both wonder and unease. We've gazed upon the destructive forces lurking within our solar system and beyond, from rogue asteroids to monstrous black holes, and even the unsettling possibility of the laws of physics themselves unraveling. With each threat explored, we've confronted a sobering truth. Earth, the cradle of life as we know it, is a fragile oasis. It hangs suspended within a cosmos governed by forces far more powerful and enduring than ourselves. The delicate balance upon which our world rests could be shattered by events we might never see coming, events that dwarf even our greatest technological achievements. And yet, it's within this very uncertainty that a strange sort of beauty emerges. As we delve into the potential ends of our world, we gain a profound appreciation for the gift of our present moment. The lush beauty of nature, the intricate workings of human civilization, the simple joy of a sunrise, all of it becomes more precious when set against the boundless and sometimes terrifying expanse of the cosmos. Perhaps our species' most significant power lies not in our ability to control these forces, but in our ability to witness them, to understand them as best we can, and to find meaning in our existence, however fleeting, in the face of such immense and uncaring power. The threats we've explored may be fictionalized or wildly improbable, but they serve as stark metaphors for the very real challenges our planet faces. Could the same curiosity and ingenuity that we've used to explore the stars help us safeguard our little blue world, to find a way to thrive alongside, rather than in spite of, the ceaseless dynamic pulse of the universe? We may never conclusively answer the question of whether we are alone in the cosmos, or if destruction is an inevitable end awaiting every world. But in our explorations, in our search for answers, we affirm to ourselves the most remarkable truth of all, that we are here, we are aware, and we have the precious opportunity to make the most of our cosmic moment in the unending story of the universe.